has been the foundation of its economic and social achievement, and will sustain China as the factory of the world with Chinese characteristics, and the market of the world with Chinese characteristics. Thirdly, the Belt and Road Initiative, BRI. China has been sharing the fruits of her development success with the developing world through BRI. To me, BRI is a platform for the developing world to lift their peoples out of poverty and become member of the shared community of prosperity for mankind. Since President Xi Jinping announced the BRI in Kazakhstan in 2013, the physical and virtual infrastructure built by Chinese engineers to Chinese engineering standard abound throughout the developing world. I've listed out all the major examples of mega projects in 5 continents that are built by China. What I want to say is this: the contribution of the physical and virtual infrastructure projects outside China under BRI has been an important factor in the social and economic uplift of those countries, and it's appreciated by the developing country. The physical and virtual infrastructure asset built by Chinese engineers and engineering throughout the engineering world is a success story that no Western government and media can deny, although they try their very best. What is very striking to me is the announcement in the G7 summit last year that they will compete with China's BRI by supporting the development of infrastructure in the developing country. I think thus they acknowledge that BRI is a great success and worthy of their imitating. Indeed, imitation is the sincerest form of flattery. But I believe their initiative is but an empty propaganda, as the infrastructure assets in the developing countries like US and UK themselves are badly in need of repair and renovation. Ladies and gentlemen, nothing symbolizes BRI better than the China-Europe freight rail service, replacing camels by trains. Since the first China-Europe freight train left Chongqing in March 2011, much to the ridicule of the West, the service had reached more than 160 cities in 22 European countries. In fact, with the COVID-19 pandemic impeding sea and air transport, the China-Europe freight train service has emerged as a reliable and economical choice in global logistics. It has truly been the lifeline for the landlocked nations of Central Asia, Eastern Europe, and even Western Europe. In ASEAN, the Pan-Asian Railway Project, originally proposed by Malaysian Prime Minister Mahathir Mohamad, has been given a great boost by the completion of the 1,000-kilometer China-Laos high-speed railway last year. Fourth, engineers and engineering. All the wonderful infrastructure in China and in the developing world mentioned above have been built by human beings, commonly known as engineers. China's spectacular development success has been underpinned by her graduating more than 1 million engineers a year from some 2,900 universities and colleges. China has been also sending hundreds of thousands of her students to study overseas in developed countries, most of them learning science and engineering from the West. What is less known is the fact that in the last 3 decades or more, the top leaders of China has been engineers like President Jiang Zemin, President Hu Jintao, and also Prime Minister Li Peng and Zhu Rongji and Wen Jiabao. Even now, President Xi Jinping is a chemical engineer. This is unique in the world. Ladies and gentlemen, engineering work in teams and engineering projects require engineers to work closely with fellow professionals like economists, financial experts, natural and social scientists. Above all, they must interact closely with government and civil society. Engineering is not an exact science. Engineers must be prudent and pragmatic as the practice of engineering impacts life and property. Time span of engineering projects are measured in years and decades. Engineers must be expert in long-term planning and risk management. I sincerely believe there must be a strong correlation between the training and practice of engineering of Chinese engineers and the remarkable successful management of China's economic and social development by engineers in the top echelon of political leadership. Now I come to the digital revolution. Currently, the world is in the throes of the digital revolution. There is a universal belief, as spoken by our previous speakers, that digital technology are the great white hope for a sustainable world. There is a universal drive to make everything digital in government, industry, and academia. This is typified by the main theme of this seminar, digital transformation of engineering ecosystem. I well remember in the last decade of the 20th century and the first decade of the 21st century, information and communication technology, ICT, was similarly regarded as the great white hope of the world. The UN World Summit on Information Society, WSIS, in Geneva 2003 and in Tunis 2005, urged all UN member states to invest heavily in ICT infrastructure so that they will not be left behind. I remember the Y2K false panic and the great number of Malaysian ICT graduates without jobs after the ICT bubble burst. Digital technology cannot by themselves make the global supply chain complete. Without the physical infrastructure in energy and water for the manufacturing sector and transportation by land, sea, and air to deliver the goods to the consumers. The factory themselves also need accessories and components from their suppliers. In the wider food sector, beside the above, the supply of fertilizer and pesticide is also important. The data centers themselves that anchor digital technology are major consumers of energy and water. Simultaneously with the proclamation of the Fourth Industrial Revolution in Davos in January 2016, the World Economic Forum released its study report, The Future of Work. It prophesies that in the next 5 years, while there will be 2 million new jobs created in digital, industrial, and services sector, there will be 7 million jobs lost in the traditional industry and services sector, leading to a net loss of over 5 million jobs. The above forecast then caused a great stir globally. Now, 6 years later, the above forecast have been proved to be false. The world has been facing labor shortage in the traditional industrial and services sector. with aging population and also what you call the declining birth rate in the developed world, will continue to face labor shortage. In the developing world, the traditional industrial and services sector will continue to be the engine for employment and wealth creation. Of course, nevertheless, the digital and internet technology are important supporting technologies, but we must not go overboard on digital technology. In engineering education, degree courses in civil, electrical, electronic, mechanical, chemical, and biological engineering, etc., must not be sidelined in favor of digital courses. The need for graduates from the traditional engineering discipline is great, especially in the developing world, as digital technologies permeate all sectors of the modern engineering. They must form important component of their course content in the traditional engineering discipline. I understand that the sustainable economic and social development of the world and solution to the global challenges of poverty and climate change will depend more on interdisciplinary solutions. It is time that the engineering profession to review engineering curriculum of all major engineering disciplines to accommodate digital technology and also to arrest the fragmentation of engineering courses. I understand there are 79 engineering disciplines recognized by the Institution of Engineers Malaysia. When the world needs engineering graduates that know more and more about more and more, why to make them so narrowly educated? They know more and more about less and less. We should consolidate engineering discipline under the traditional major disciplines of engineering. I am actually a strong believer of walking the talk. So I want to tell you some of my current initiatives. First, my first initiative is China to be the voice of engineering, global engineering. I've downloaded my proposal in the chat box. Engineering in both science is both science and art. Engineering progress and innovation are driven by practical experiences in engineering projects on the ground. Thus, most current and future engineering innovation must be by Chinese engineering because they are doing most engineering projects on the ground. One of the major initiatives in becoming the voice of global engineering is that China must renew and focus their effort in the accreditation of all their professional engineers, the graduates from 2,900 universities. I think that they should actually make sure that these engineering graduates and professional engineers can move across all the countries to practice in all the Belt and Road countries. And I think that they should take an example from the ASEAN Engineers Register of the ASEAN Federation of Engineering Organization that is administrated by Institution of Engineers under the ASEAN Mutual Recognition Agreement on Engineers. I think this is one thing that AFIO and IEM can contribute to to making China the global voice of engineering. The second is an initiative called Data at China 100 Universities project. Now, the development of the data industry and technology has become an increasing pillar of China's industrial upgrading and economic development, as data or big data is a foundation of digital technology. But China is realizing that they face a shortage in actually providing enough number of graduates in digital technology, big data, and artificial intelligence. So before 2017, there are no big data discipline in Chinese university, making it very difficult to cultivate relevant big data talent. So in order to solve the problem, in 2016, the Chinese Ministry of Education and the Guang Information Industry jointly launched the Data at China 100 University project. Now, this project is actually to make the Chinese digital technology industry, which now drive a lot of innovation in China, because they invest 15% of the annual turnover in R&D, for them now to mentor the Chinese technical university and colleges to provide enough engineering graduate for the industry. Now, they are focused by the Chinese mega multinational corporations building big data and artificial intelligence data innovation center in Chinese universities. And they are focused on this. First, use of big data and AI to improve efficiency of administration in the university. And the academic staff exchange between corporations and universities, provision of big data and AI training materials to universities, and short-term training attachment of graduates and undergraduates in corporation and in their projects, and fostering big data and AI center to apply digital technology to upgrade the local economies. I have managed to persuade this Data at China 100 University project to extend the benefit of this very important China enterprise and university cooperation project to 100 universities in Belt and Road countries, so that the Chinese universities and corporations can mentor the 100 universities in Belt and Road countries to upgrade the digital technology skills and also the digital related economies. But unfortunately, this initiative has been stalled by the COVID-19 pandemic. Third, I want to talk about the ASEAN Academy of Engineering and Technology and the Chinese Academy of Engineering, the cooperative program in traditional medicine. As you know, in China is the only country that successfully combat COVID-19, and a lot of the credit must be due to the application of traditional Chinese medicine. So I think that this initiative will share the benefits of Chinese traditional medicine with ASEAN countries. This said, ASEAN countries have also a rich heritage of and tradition of their own traditional medicine, especially the tropical rainforests are a source of very important medical resources and materials. So I hope that this cooperative project will actually enhance traditional medicine in ASEAN countries and China. This program is managed by the UNESCO International Knowledge Center for Engineering, Science and Technology, success of the Chinese Academy of Engineering and also University Tunku Abdul Rahman, Utah of Malaysia. Fourth is the guideline for schools for epidemic prevention and control. Now, in the UN Broadband Commission, because of COVID, there has been a very great push for online education. But I have actually been against too much online education because education, physical face-to-face education, it's a tradition of human civilization. And in fact, in STEM subjects, you cannot replace a physical lab, lab experiment in schools by digital simulation. So I have been also seeing that the schools in most countries, they can be a major source of super spreader of COVID-19 because so many sectors of the community are involved in school. So I have actually asked that we should actually make schools safe for epidemic, not only now the school building safe for epidemic, but also for future epidemic. I'm very pleased that IEM is working on guidelines to make Malaysia school safe from epidemic. Fifth, I want to just say the global epidemic management system. This is also one project that the UN Broadband Commission is very much engaged in. Now, I do believe that if we can share all the data about the experience in COVID-19 together, we can tackle future epidemics much better. And of course, the experience in combating COVID-19 is in test, trace, and isolate. So now that require the database of all the citizens of the world, as many as possible. So the biggest database now is from mobile phone operator and subscribers, because mobile phone subscriber now actually constitute some 90% of humankind. If all the mobile phone subscribers data can be collated together and used together, and also through their global roaming facility, their travel and tourist activity throughout the world can also be identified, then we would form a global database for successful implementation of test, trace, and also isolate. And I think with digital technology, big data, and AI, we might be able with this comprehensive database to actually identify some abnormal outbreak in certain area of the world, and then quickly isolate it so that the epidemic will not become a global pandemic. Finally, I want to speak a little bit about the South-South Institute for Infrastructure Maintenance Malaysia, SIM. Now, since 2010, the ISTIC has been actually working together with IEM Training Center to promote the training course in maintenance of infrastructure of engineers and technicians. And this initiative, we have got tremendous backing from Shahbaz Khan. And so this course has been supported by all major players in Malaysian in the construction industry, like the CIDB Construction Industry Development Board, the Master Builders of Association of Malaysia, Board of Engineers, Highway Authority, etc. But what I want to stress is that most foreign participants of these courses have praised Malaysian infrastructure assets as first class and their maintenance as first class. So I have persuaded IEM to establish this SIM to make training course more structured, focused, and regular. And this I have now asked under the IEM CAS MOU that CAS will provide trainers in digital technology, which actually now permit all sectors of infrastructure, maintenance, construction at all. But I will also try to obtain the support of Huawei Malaysia that in 2012 established the Malaysian Global Training Center in Cyberjaya. They have trained actually more than 10,000 individuals in the latest technology such as 5G, AI, and cloud computing. Huawei Malaysia is also actively collaborating with local Malaysian ICT service provider and academic institution to further develop ICT and digital solutions for various applications. By the way, I would strongly recommend IEM to arrange visit to Huawei Customer Service Center in Kuala Lumpur to see in their exhibition how digital technology permit all sectors of the economy in China. Thank you very much.
Thank you,